All right, let's try this problem over here. We're going to use a brand new approach. First thing I want to start out with something I'm sure you know. We'll call this 10 newtons, and we'll call this 40 newtons. So this is a brand new approach. So listen carefully. The best way to do this problem, of course, is to find the acceleration. Of course, it's this, F equals ma. Now, I hope you recognize that we've got we haven't said there's no friction mentioned. So the first thing you should recognize is that there's a heavy weight on the left side. So this system's going to accelerate in the counterclockwise direction. And so the best way to handle a problem like this, when you have forces on the outside of your system, you know that this is 10 newtons and this is 40 newtons. And you know what? What's the net force? Well, there's a counterclockwise force of 40 and there's a clockwise force of 10, and they're competing against each other. What's the net force? Well, yeah, get ready. What we're going to say is, okay, let's treat counterclockwise as positive, just because I know my system's going to go in that direction. Let's treat anything in this direction as negative. So 40 Newton force is positive, the 10 Newton force is negative, and equals m. Now pay attention. What's being accelerated by these two forces? Well, both masses, right? Both 4 plus 1. Both masses are being accelerated by this net force. So 30 newtons equals 5a. So a equals 6.0 meters per second squared. So let's go over that again. I have a system that's got some clockwise forces and counterclockwise forces, and I recognize that the counterclockwise forces are greater, 40 newtons, and I just do not some of the forces in the x direction, but some of the forces in the clockwise directions equal ma. So there's a direction. I call this positive because I know my system is going to go in the counterclockwise direction. So there's a positive force competing against a negative force of 10, and that all sums up to 30. What's being accelerated by that force? The total system is being accelerated. The 1 and the 4 are being accelerated actually with the same acceleration of 6.0 meters per second squared, or 6.0 meters per second squared counterclockwise. Both are true. Okay, so that's interesting. Remember, our pulleys are massless until the fourth quarter. And one more thing. This tension equals this tension. Now, actually, why did I find the acceleration? Remember, N, F, A, T. There's no friction. You can't find the tension unless you find the acceleration. So I haven't even answered the question yet. So now I've got the acceleration and I can find the tension. Now what I'll do is I can pick either side to do that. And now I isolate on a particular object because I want to find t. Once I have the acceleration, I want to find t. So what I think I'm going to isolate on the left. Either one will give me the same answer. So let me clean this up a little bit. It's tough to look at. Okay. So I'm going to isolate and have tunnel vision. This is the only thing that exists. This is the only thing that exists in my system. It's a 4 kilogram body with two forces on it. So there's a positive force going, the direction we call positive. Sum of the forces equal ma, 40 newtons. That's positive force, minus t, the unknown tension, equals m. Now, what is being accelerated by the 40 and the t? Only the 4 kilogram, which we're going to make 4 kilogram, 4.0. And the acceleration, we got a 6.0 meters per second. Whoops, let me clean that up a little bit. 6.0, get out of there. Meters per second squared is what we found from before. And so 40 minus T equals 24. And so I could take it over here. I'm going to take it over here. So 40 equals 24 plus T, and T equals 16 newtons. That means both sides are 16 newtons. Let me double check. Yep, good. Got the right answer. So T is 16 newtons. So let's go over that because that's brand new. We have a system that doesn't, you can't say that it moves to x in the x direction, the y direction. It moves in the way we look at it, moves in the counterclockwise direction. We have two competing forces, one working counterclockwise, which is the 40, one working, counterclockwise is 40, the clockwise is 10, and they're competing against each other. And it's the result of these two forces where you get the acceleration. What does it accelerate? So we call this positive direction, the direction of the movement. So the 40 is positive because it goes in that direction. The 10 opposes that motion. It's a negative. And so that brings us 30 equals m. Now, what's being accelerated by those two forces? Both objects, the 4 and the 1, are being accelerated. So we say 5 kilograms. And we find the acceleration 6 meters per second squared. Well, why did I find the acceleration when they asked for the tension? Well, because I cannot find the tension unless I know the acceleration, because it's NFAT. So I got that the acceleration is 6 meters per second counterclockwise. Now, I got the answer using the left one, but what if I use the right one? Let's clean this all up because it really is pretty much a mess. So I said it didn't matter which side I used, I would still get 16 newtons was the tension. And remember that the tension is the same on both sides. This tension equals this tension. Let's do on this side. So let's do the same procedure, and I'll show you that we get the same number. So isolate, tunnel vision on this body. So sum of the forces equal ma, isolating. What are the positive forces? Well, T is a positive force because it goes in the direction we called positive. So T, the weight force is the negative direction, 10 newtons, equals m. What's our m? What's being accelerated by these forces? Only the 1 kilogram. And what was our acceleration? We found it to be 6 meters per second squared. So T minus 10 equals 6. And once again, we found that T equals 16 newtons. Now that's, waste of time. Once you get one, you shouldn't do the other one because they're both equal, because this is a massless pulley and frictionless pulley. There's no mention of frictionless and there's no mention of mass. So that's something we'll have to continue to practice with because that's brand new.